Human beings have always feared death, but beneath the fear of dying lies something deeper, the fear of being forgotten. To vanish without trace, to leave no memory behind, is a terror that haunts every culture. Death may end life, but forgetting ends meaning. If no one remembers, was a life ever truly lived? This existential anxiety has shaped myths, monuments, and even scientific quests for permanence. Cultures across time have invented ways to outwit oblivion. Ancient Egyptians built pyramids, stone tombs designed to preserve both the body and the memory of rulers. Chinese emperors were entombed with armies of clay, a silent testimony meant to echo through centuries. Even the simplest grave markers carved with names reflect the desire to resist erasure. To be remembered is to endure. To be forgotten is to die twice. Religions, too, offer promises against forgetfulness. Christianity speaks of eternal life in heaven, where the faithful are held forever in divine memory. Hinduism and Buddhism promise cycles of rebirth, ensuring that the soul never disappears but continues its journey. In these traditions, oblivion is impossible. Existence itself is permanent, whether in divine awareness or in karmic cycles. These myths provide comfort, offering continuity beyond the fragile span of one lifetime. Science, however, paints a harsher picture. Physics tells us that stars burn out, galaxies collide, and even memory encoded in matter cannot last forever. Entropy ensures that all structures, even civilizations, eventually dissolve. From this perspective, permanence is an illusion. To the cosmos, human lives are brief sparks against an indifferent backdrop. No monument can withstand eternity. No culture can preserve memory forever. Scientific impermanence confronts us with the possibility that forgetting is inevitable on the largest scale. This contrast between cultural immortality, myths, and scientific impermanence defines the tension of human existence. We crave meaning, yet the universe does not guarantee it. We yearn for remembrance, yet the cosmos offers only silence. The fear of being forgotten emerges from this gap, a psychological wound created by the mismatch between our desire for permanence and the reality of impermanence. But the fear is not only cosmic, it is personal. Each person wonders whether their life will matter, whether their name will be remembered by children, friends, or history. Even small acts of memory, photographs, journals, stories become tools to preserve presence. Digital culture continues the tradition. Social media profiles remain after death, archives of lives stored on servers. We build virtual pyramids now, seeking the same comfort as ancient rulers, and yet, forgetting is also part of the human condition. Memory fades even within a single life. Faces blur, names slip, histories are rewritten. What one generation treasures, another discards. To live is to be remembered for a time, and then to dissolve into the larger current of forgetting. This truth can be frightening, but it can also be freeing. If nothing lasts forever, then meaning must be found not in permanence, but in presence, in the way life is lived, not in how it is remembered. The fear of being forgotten cannot be eliminated, but it can be reframed. Monuments crumble, memories fade, but each life leaves ripples, however small, in the stream of existence. Whether in a child's memory, a scientific discovery, or a fleeting kindness, traces remain, even if only for a while. And perhaps that is enough, to live knowing that memory is fragile, but that presence is real. Memory in nature. Memory is not only a human phenomenon. Across nature, systems preserve traces of the past, storing information in ways that shape the future. To examine memory in nature is to recognize that the act of remembering is far older and broader than human consciousness. From the delicate workings of neurons to the vast imprints of the cosmos, memory is woven into the fabric of life and matter itself. In biology, memory begins at the cellular level. The immune system, for instance, remembers pathogens. After encountering a virus, it encodes information in specialized cells that prepare the body for future defense. This is not conscious memory, yet it functions as a record of experience, a biological diary written in molecules. Plants too carry forms of memory, adjusting growth or flowering patterns based on past conditions. Nature, at every scale, finds ways to preserve traces of what has happened. Human memory, by contrast, is fragile. Neurons encode experiences through changes in synaptic strength, forming networks that allow us to recall the past. But memory is fallible, easily distorted or lost. We forget names, misremember events, and even fabricate details that never occurred. Memory shapes identity, yet it is unreliable, a shifting reconstruction rather than a fixed archive. In this sense, human memory reflects both the power and the vulnerability of biological remembrance. Cosmic memory, however, is more enduring. The universe itself carries imprints of its history. The cosmic microwave background is a snapshot of the early cosmos, light stretched across billions of years that still whispers the conditions of the Big Bang. Geological layers preserve the story of Earth, each stratum a page in the planet's autobiography. Fossils carry echoes of vanished species. Even DNA can be read as a memory of evolutionary history, encoding millions of years of adaptation and survival. The contrast is striking. Human memory fades within decades, but cosmic patterns endure for eons. Where the individual mind forgets, the universe remembers. A supernova leaves a nebula that lingers for millennia. A glacier carves valleys that remain long after it melts. Nature, in its many forms, resists forgetting, embedding the past into structures that guide the future. And yet, even cosmic memory is not absolute. Entropy erodes order, scattering information. Over immense timescales, even stars and galaxies dissolve, their histories blurred into heat. Memory, whether biological or cosmic, always faces impermanence. The difference is scale. A human forgets within years, while the cosmos forgets within billions of years. The lesson is sobering, but it also places human fragility in perspective. By examining memory in nature, we glimpse both continuity and impermanence. Memory is not unique to us, but part of a universal principle. Systems carry traces of their past. Yet memory at every level is temporary. What endures longest are not details, but patterns, rhythms of growth, cycles of stars, codes of DNA. In this way, nature shows us that forgetting is inevitable, but that forms can echo long after particulars vanish. To recognize memory in nature is to see ourselves mirrored in the cosmos. We forget, yet we also leave traces. Our fragile minds are part of a continuum that stretches from molecules to galaxies. And though nothing lasts forever, the act of remembering even briefly is enough to connect us to that larger story. The universe, as a record keeper. For much of human history, oblivion seemed inevitable. Memories fade, monuments crumble, and civilizations vanish into silence. To be forgotten appeared to be the natural fate of all things. Yet modern physics suggests a startling alternative. Perhaps the universe is, in some sense, a record keeper. Information, according to many theories, may never truly vanish. Instead of being lost, it is preserved, transformed, hidden, or encoded in ways we do not yet fully grasp. The principle begins with the law of conservation of information. In physics, information is understood as the arrangement of states within a system. While energy can change form and matter can shift, the underlying information describing these processes may remain eternal. This principle gained prominence in debates about black holes. Stephen Hawking once suggested that anything falling into a black hole, including information, would be destroyed. Yet later work, supported by quantum theory, argued that information is never erased but scrambled at the event horizon, preserved in subtle patterns of radiation. If true, then even the most extreme conditions in the universe cannot annihilate memory. This challenges the traditional picture of oblivion. On the human scale, memories fade and records decay, but on the cosmic scale, traces endure. The photons that leave your body when you move, the heat released by your actions, the ripples of gravity stirred by your steps, all encode information. You may vanish from living memory, but the universe continues to carry faint imprints of your existence. Like a vast archive, it stores the traces of everything that has ever occurred. The contrast between oblivion and conservation is profound. Oblivion suggests that existence collapses into nothingness, leaving no residue. Conservation suggests that existence is permanent, woven into the cosmic fabric. The difference is not only scientific but existential. If information never disappears, then in some sense, nothing is ever entirely lost. The universe itself becomes a witness. Skeptics note that conservation of information is not yet fully proven. The black hole debate continues, and the mechanisms of information storage at cosmic scales remain unclear. Some argue that while information may persist in principle, it can become so scrambled as to be practically unrecoverable. From a human perspective, this may be indistinguishable from loss. Yet even so, the idea that the universe refuses to forget resonates powerfully. This vision transforms how we see memory. It suggests that the cosmos itself is a record keeper, inscribing every particle's motion, every quantum fluctuation, into its unfolding story. Human records may fail, but universal records may be indelible. Even the fleeting spark of thought encoded in neural firings and electromagnetic signals contributes to this cosmic archive. Philosophically, this idea blurs the line between science and spirituality. The thought that no action is lost echoes religious traditions that speak of divine memory, cosmic judgment, or karmic record. In physics, it is not divine will but quantum law that guards against oblivion. Yet, the emotional effect is similar, a reassurance that existence is never meaningless, that the universe holds every trace. To imagine the universe as a record keeper is to glimpse continuity amid impermanence. Our names may fade, but our existence leaves ripples in the cosmic archive. Whether or not those ripples can ever be read, they remain part of the story of reality. And in that sense, nothing is truly forgotten. The arrow of forgetting. Few scientific ideas have escaped the laboratory to shape culture as much as entropy. It is often invoked in everyday language as a synonym for chaos or disorder, a force that drags all things into ruin. But in physics, entropy is far more subtle and far more precise. To understand entropy is to understand how the universe evolves, how memory persists, and why time itself seems to flow in one direction. Entropy originates in the laws of thermodynamics, the science of heat and energy transfer. The second law famously states that the total entropy of an isolated system never decreases. But this does not mean that systems collapse into pure chaos, as the popular picture suggests. Instead, entropy measures the number of possible microscopic arrangements that correspond to the same macroscopic state. In other words, entropy is a measure of probability. Consider a box filled with gas molecules. The molecules could be arranged in countless ways, bouncing off one another with different velocities and positions. If they all cluster in one corner, that's an extremely unlikely arrangement low entropy. If they spread out evenly, that's far more probable high entropy. The second law tells us that systems naturally evolve from less probable to more probable states. Entropy increases not because order magically decays into disorder, but because probability favors the many over the few. This statistical view of entropy reveals why time seems to have a direction. At the microscopic level, the laws of physics are reversible. A film of colliding particles could run forward or backward without contradiction. But macroscopically, we see entropy rise. A shattered glass does not reassemble. Smoke does not return to a cigar. The arrow of time emerges not from fundamental laws, but from the overwhelming tendency of systems to evolve toward higher probability states. Entropy is the mathematics of inevitability. The popular association of entropy with chaos is not entirely wrong, but it misses nuance. High entropy does not mean messy in the everyday sense. It means more possible microstates. A shuffled deck of cards has higher entropy than a perfectly ordered one, but both are equally structured in appearance. Entropy is less about visible disorder and more about hidden possibilities. It is about what is statistically likely, not what looks neat. This distinction matters when we apply entropy to larger questions. When people say the universe tends toward disorder, they often imagine meaninglessness. But entropy is not nihilism, it is mathematics. Far from erasing meaning, it provides the framework for understanding why stars burn, why life evolves, and why memory is fragile. Entropy explains both decay and creation, both the fading of systems and the emergence of complexity within them. Indeed, one of the paradoxes of entropy is that local order can arise even as global entropy increases. Life itself is an example. Organisms build highly ordered structures, but in doing so, they release heat and increase the entropy of their environment. Complexity thrives because the universe has gradients of energy to exploit. Entropy, in this sense, does not forbid order. It drives it. The contrast between the cultural and scientific meanings of entropy is striking. Popularly, it is chaos, collapse, despair. Scientifically, it is probability, precision, inevitability. Where one sees disorder, the other sees statistics. Where one sees death, the other sees transformation. To grasp what entropy really means is to see beyond cliché. It is not a doom-laden force, but the mathematical rhythm of change. It governs how systems evolve, how time unfolds, and how possibility expresses itself in the universe. Far from being the enemy of meaning, entropy is the canvas upon which meaning is drawn, the measure of what can happen, and why it almost always does. The arrow of time. Among the great mysteries of physics, few feel as intimate as the arrow of time. We live our lives moving forward. We remember the past but not the future. We age rather than grow younger. We see broken objects scatter but never reassemble. And yet, at the fundamental level, the laws of physics are time-symmetric. Equations describing the motion of particles work equally well backward or forward. Why then do we experience time as irreversible? The answer lies in entropy. Entropy, as introduced by the second law of thermodynamics, always increases in an isolated system. That steady rise creates directionality. A deck of cards may start ordered, but through shuffling tends toward disorder. A drop of ink in water diffuses outward but never gathers back together. These processes define forward as the direction of increasing entropy. If we flip the film of ink dispersing, the reversed motion looks absurd because it violates probability. Entropy gives time its arrow by favoring the overwhelmingly likely over the vanishingly rare. This explanation reveals a striking contrast. At the microscopic level, time is symmetric. The collision of two particles could be reversed without contradiction. But at the macroscopic level, the scale of glasses, planets, and people time flows in one direction. The irreversibility we experience is not a law of particles themselves, but of aggregates, a property of probability written large. Human experience aligns with entropy because we inhabit systems where the improbable rarely manifests. Memory illustrates this divide vividly. We remember the past, not the future, because the brain itself is an entropic system. Memories are physical traces, changes in neurons and synapses that accumulate as entropy rises. The future leaves no such imprint. It is only potential. Thus, our psychological arrow of time arises from the physical arrow. Irreversibility is not only external but embodied, stitched into the way cognition encodes reality. Still, the arrow of time is not absolute. In certain isolated conditions, entropy can locally decrease. Refrigerators pump heat outward to create order inside. Gravitational systems like stars form structured bodies from diffuse clouds. Yet these examples do not violate the second law because local decreases are offset by larger increases elsewhere. Globally, entropy continues to climb, and the arrow of time continues to point forward. The contrast between timeless physical laws and irreversible human experience highlights a profound philosophical tension. Physics at its core suggests a block universe where past and future coexist equally, all written in the fabric of space-time. But human life insists on flow. We live moment to moment, bound to an arrow that feels undeniable. Are we wrong to feel time passing, or is there more to temporal experience than physics reveals? Some thinkers suggest that the arrow of time may itself be emergent, arising from boundary conditions at the birth of the universe. The Big Bang may have begun in a state of extremely low entropy, setting the stage for entropy to rise ever since. If the cosmos had started differently, perhaps our sense of direction would not exist at all. In that sense, time's arrow is not a fundamental property of reality, but a cosmic accident, one that makes memory, history, and narrative possible. For humans, the arrow of time carries existential weight. It is the reason we grow, change, and eventually die. It is the source of nostalgia, hope, and loss. Even if physics suggests that time is ultimately symmetric, our lived reality insists otherwise. And perhaps that insistence is itself meaningful, a reminder that being human means inhabiting not equations, but experiences. The arrow of time, then, is both physical and personal. It defines the unfolding of the universe and the rhythm of our lives. It may be born from probability, but it becomes the stage upon which memory, meaning, and mortality are written. Death, decay, and information loss. Entropy is not just an abstract principle of physics. It is the slow pulse of decay we witness all around us. Buildings crumble, bodies age, memories fade. Entropy explains why time leaves ruins in its wake. Death and decay are not anomalies, but the natural unfolding of physical law. Yet when we look closer, the story becomes more complex. Structures dissolve, but does information, the record of what once was, ever fully disappear? At the physical level, death is the breakdown of order. A living organism maintains itself by constantly exchanging energy with its environment, keeping entropy at bay. But eventually the balance fails. Cells falter, tissues degrade, and the intricate order of life unravels. Decay continues the process, scattering molecules back into simpler states. What once was a coherent system disperses into the environment, each step an increase in entropy. In this sense, death is entropy's triumph. Complexity gives way to probability, and order dissolves into randomness. The same principle applies beyond biology. Stars burn their fuel and collapse. Civilizations rise and fall, leaving behind weathered ruins. Even digital data, which feels permanent, degrades when the medium storing it corrodes. Entropy ensures that every structure, however grand or humble, will one day succumb to dissolution. To exist is to fight a temporary battle against this inevitability. Yet entropy does not tell the whole story. While structures dissolve, traces remain. Physics suggests that information may not vanish entirely. A burned book is no longer readable, but the ash, smoke, and heat still encode details of what once was. A decayed body disperses, yet its atoms carry histories of stars long dead. Even as order collapses, information lingers in altered forms. This principle lies at the heart of the black hole information paradox, where physicists debate whether matter falling into a black hole is truly erased. Many now believe it is not information is scrambled but conserved, hidden in subtle imprints that outlast apparent destruction. This raises a profound contrast between physical dissolution and informational persistence. Decay destroys form, but perhaps not essence. Memory, in this broader sense, may outlive structure. The universe itself becomes a record keeper, preserving traces even as entropy advances. Every life, every event, every structure leaves echoes written into the distribution of energy and matter. From this perspective, death is not total annihilation, but transformation, a shift in how information is stored. Still, for humans, the psychological weight of decay remains. We do not grieve only the persistence of atoms. We grieve the loss of form, of patterns we loved. The ashes of a book may contain information, but not the story. The scattered molecules of a loved one may endure, but not their laughter or presence. Information may be eternal in principle, yet in practice it becomes inaccessible, scrambled beyond recognition. Oblivion may not exist physically, but emotionally it feels real. This duality deepens the mystery. On one hand, entropy guarantees dissolution. On the other, physics resists true erasure. Death and decay confront us with the fragility of form, but they also point to the resilience of memory at cosmic scales. Perhaps the meaning of existence lies in this tension. To live is to create temporary patterns of order, knowing they will dissolve, yet trusting that something of them, some trace, will persist. Entropy teaches us that everything changes, but conservation of information suggests nothing is ever truly lost. Between these two truths lies the paradox of death and memory. The body decays, the structure dissolves, but the universe remembers even if we can no longer read the record. The indestructible currency, for centuries, physics described reality in terms of matter and energy. Matter provided substance. Energy drove change. But in the last century, a new contender has entered the stage: information. Increasingly, scientists and philosophers suggest that information is not just a property of matter and energy, but the very foundation of reality itself. What we call particles, forces, and even space-time may emerge from the deeper bedrock of informational structure. The roots of this idea lie in information theory. Pioneered by Claude Shannon in the mid-20th century, Shannon defined information as the reduction of uncertainty, the measure of how much you learn when you receive a message. From this seemingly abstract definition grew the digital revolution: computers, communication networks, and artificial intelligence. Information proved not only to describe signals, but to govern the flow of meaning and structure in systems. Physics soon caught up. John Archibald Wheeler, one of the great theoretical physicists, famously coined the phrase "it from bit." He suggested that every particle, every quantum event, every field is at root a manifestation of binary choices: yes or no, 1 or 0. Reality in this vision is digital at its core. Matter and energy are emergent properties. Information is primary. The universe is not a machine, but a computation. This contrasts sharply with the classical picture. In Newton's world, matter was solid and continuous, moving through an infinite stage of space and time. Even Einstein's relativity, revolutionary as it was, still treated matter and energy as the players. But if information is fundamental, then matter and energy are not the stage or the actors, they are the script. Reality itself becomes code, and the cosmos unfolds as its execution. Quantum mechanics reinforces this shift. At the quantum level, particles are not fixed entities, but probability distributions, described by information in wave functions. Observation collapses possibilities into actualities, an informational update more than a mechanical collision. Quantum entanglement, too, is best described informationally. What matters is not distance, but correlation, the preservation of relational information across space. Physics, viewed this way, becomes the study of information flow. If information is fundamental, then many mysteries gain new context. Black hole physics, for example, revolves around whether information is lost when matter falls beyond the event horizon. The prevailing view is no, information is conserved, albeit scrambled, woven into subtle correlations in radiation. This aligns with the principle that the universe, at its deepest level, refuses to forget. Critics caution that information is a slippery term. In Shannon's sense, information requires a receiver and context. Applying it to fundamental physics risks stretching the metaphor. Others argue that information is descriptive, not ontological, that it tells us about systems, but is not itself the stuff of reality. Yet even skeptics acknowledge the power of the idea. Treating reality as information unites disparate domains, from quantum mechanics to cosmology, under a common conceptual framework. Philosophically, The implications are profound. If information is the base reality, then consciousness too may be reinterpreted as informational processing. Thought, memory, and perception would be not anomalies, but natural expressions of the universe's fundamental currency. Life itself becomes an informational phenomenon, a complex pattern woven into the fabric of cosmic computation. To view information as fundamental is to see reality differently. Matter and energy no longer stand alone as ultimate. They are expressions of a deeper logic. The universe is not a stage upon which things happen, but an evolving record of information, one that contains every event, every trace, every possibility. In this vision, we do not simply live in the universe. We live in its code, black holes, and the information paradox. Few objects in the cosmos capture the imagination like black holes, regions of space-time so dense that nothing, not even light, can escape their gravity. They are engines of mystery pushing physics to its limits. But beyond their exotic nature lies a profound puzzle about memory and reality itself. The information paradox. Do black holes destroy information, or does the universe preserve it in ways we are only beginning to glimpse? Stephen Hawking revolutionized our understanding of black holes in the 1970s when he showed that they are not completely black. Through quantum effects at the event horizon, black holes emit faint radiation, now called Hawking radiation. Over immense timescales, this radiation allows black holes to evaporate entirely. The catch is that Hawking radiation appears to carry no information about what fell into the black hole. If true, this means information about matter, energy, even entire stars would be erased from the universe. Such destruction violates the principle of information conservation, one of the bedrocks of physics. This is the paradox. Quantum mechanics insists that information cannot be lost, while Hawking's calculations suggested that black holes do precisely that. Oblivion and conservation clash at the heart of reality. Over the decades, several solutions have been proposed. One of the most influential is the holographic principle, developed by Gerard 't Hooft and Leonard Susskind. According to this idea, the information about everything that falls into a black hole is not destroyed, but encoded on its surface, the event horizon. Just as a two-dimensional hologram can project a three-dimensional image, the horizon of a black hole may store the information of its contents in a scrambled form. From this perspective, black holes are less like cosmic shredders and more like ultimate record keepers, writing everything that happens onto their boundary. The holographic principle has profound implications beyond black holes. It suggests that the universe itself may be holographic, with the three-dimensional reality we experience emerging from information encoded on a two-dimensional surface. If true, then what feels like solid matter and spacious cosmos may be a projection of deeper informational patterns. Oblivion gives way to conservation, not through brute permanence, but through elegant transformation. Critics point out that while the holographic principle is mathematically compelling, it is not yet empirically proven. Other proposals exist as well. Some suggest that information leaks out gradually through subtle correlations in Hawking radiation. Others argue that new physics, perhaps involving wormholes or quantum gravity, will eventually resolve the paradox. The debate remains open, a frontier where physics, philosophy, and imagination intersect. The contrast between apparent destruction and conservation is striking. To the eye, black holes seem like erasers, swallowing matter and light without return. To physics, they may be archives, preserving information in ways that defy intuition. Whether through holography, subtle radiation, or hidden dimensions, the universe may refuse to forget. Philosophically, the paradox touches the core of human anxiety. Is anything truly lost? If black holes conserve information, then even the most violent erasures in the cosmos are not absolute. Patterns may dissolve, but memory endures in the fabric of space-time. If not, then oblivion is real and the universe itself forgets. Either way, black holes confront us with the fragility of meaning and the resilience of reality. The information paradox remains unsolved, but its very existence reframes how we think about the universe. It tells us that memory and loss are not only human concerns, they are cosmic ones. And in the heart of the darkest objects in space, the universe may be keeping secrets written in light too faint for us to yet decode. Does the universe remember everything? If physics suggests that information cannot be destroyed, then a haunting question follows. Does the universe, in some sense, remember everything? From the faint afterglow of the Big Bang to the subtle ripples of gravity left by colliding stars, reality appears to carry its own archive. Each event leaves an imprint, however faint, embedded in the fabric of existence. But what does it mean to say the universe remembers? Is this mere metaphor, or could it hint at something closer to soul? In physics, the conservation of information is precise and mathematical. It means that the details of a system's state, its particles, their positions, their energies, are never truly erased, even if they become scrambled beyond recognition. A burned book is gone as a coherent object, yet the ash, smoke, and photons radiated still encode traces of its existence. At the cosmic scale, black holes may function similarly, storing information on their horizons rather than annihilating it. In this scientific sense, the universe does remember, though not in the way humans imagine memory. It is not narrative but statistics, not story but state. Mystical traditions interpret this differently. Many religions and philosophies propose that nothing of soul or self is ever lost. In Hinduism and Buddhism, karma functions as a cosmic ledger, recording every thought and action across lifetimes. Abrahamic traditions speak of divine judgment, where deeds are remembered and weighed. Indigenous worldviews often regard the earth or cosmos itself as conscious, a witness to all that unfolds. For mystics, the universe's memory is not mathematical but moral. It is not just data that endures, but meaning. The contrast between these views is stark. Science describes memory without intention. The universe conserves information because its laws require it, not because it chooses to preserve meaning. Mysticism sees memory as purposeful, entwined with justice, continuity, or cosmic compassion. One offers inevitability, the other offers reassurance. Yet both grapple with the same anxiety, the fear of oblivion, the desire that nothing we are or do should vanish entirely. Some thinkers attempt to bridge the two. They speculate that if information truly persists, then perhaps consciousness too is woven into the cosmic record. The electromagnetic fields generated by every brain, the patterns of thought encoded in every neural firing, could these leave subtle traces in the universe's archive? If so, then even after death, some record of mind might remain, not in a personal sense of memory, but as part of the cosmos's informational fabric. Science does not confirm this, but the possibility resonates with the human yearning to be remembered. Skeptics warn against confusing metaphor with mechanism. To say the universe remembers is to anthropomorphize physical law. Information conservation is not the same as awareness, and physics does not imply narrative continuity. The ashes of a book may hold information, but they do not hold the story. Similarly, the persistence of quantum data may not mean that our lives, as we lived and felt them, are stored in cosmic consciousness. And yet the mystery endures. Whether through photons carrying whispers of ancient stars or myths of divine remembrance, humanity cannot shake the intuition that nothing is ever wholly lost. Perhaps this is less about what the universe does and more about what we need. To believe in memory, whether physical or spiritual, is to believe that existence matters. Does the universe remember everything? Science leans toward yes, but without meaning. Mysticism insists yes with purpose. Between them lies the space of awe, the possibility that every life, every thought leaves ripples that endure, woven forever into the strange memory of the cosmos. The soul in science and philosophy. Long before physics spoke of information or biology described neurons, philosophers sought to explain the riddle of human existence through the idea of the soul. To the ancients, the soul was the essence of life, the immaterial principle that animated the body and endured beyond death. Even today, echoes of these classical views shape how we imagine identity, memory, and immortality. Plato offered one of the most influential accounts. For him, the soul was eternal, existing before birth and surviving after death. In his dialogues, he argued that the soul belongs to the realm of forms unchanging, perfect realities that underlie the shifting material world. The body, by contrast, was a temporary vessel, fragile and corruptible. In this framework, death was not annihilation, but release, the soul's return to the higher reality from which it came. The promise of immortality lay in the soul's participation in truth itself. Aristotle took a different approach. While he too believed in the soul, he defined it less as a separate entity and more as the form of the body, the principle that gives matter its life and organization. Plants, animals, and humans all had souls, but of different kinds. The human soul was distinguished by reason, the capacity to think and reflect. Unlike Plato, Aristotle did not imagine the soul floating free of the body. It was intimately bound to it, shaping and animating it. Yet, he left open the question of whether some part of the rational soul might endure after death, hinting at immortality without insisting on it. Centuries later, Descartes revived and reshaped these ideas. Living at the dawn of modern science, he drew a stark line between mind and body. For Descartes, the body was a machine, governed by physical laws, while the mind or soul was a non-material substance, the seat of thought and selfhood. I think, therefore I am captured his conviction that consciousness was the one undeniable certainty, irreducible to mechanism. This dualism influenced Western thought profoundly, framing the soul as separate from the physical world and thus potentially immortal. The contrast between the classical soul and the mechanistic body was powerful because it offered hope against death. The body could decay, but the soul, immaterial and eternal, might persist. Religious traditions built upon this foundation, weaving visions of heaven, judgment, and rebirth. The soul became not only the explanation of life, but the guarantee of continuity, an answer to the fear of being forgotten. Modern science has largely dismantled this framework. Neuroscience shows that thought and memory correlate with brain activity, challenging the idea of a separate, immaterial soul. Physics explains the body mechanistically without invoking metaphysical principles. To many, the soul has become an outdated hypothesis, replaced by biology and information. Yet the persistence of the concept testifies to its psychological and cultural power. People continue to speak of soul when describing depth of feeling, artistic genius, or moral character. The word endures because it names something experience alone cannot explain. The tension remains unresolved. On one side lies the classical image, the soul as immortal essence distinct from the perishable body. On the other lies the scientific image, the mind as emergent, inseparable from the brain's machinery. Between them stretches the human longing to believe that who we are is more than flesh, that identity, memory, and love might outlast decay. To explore the classical soul is not only to revisit ancient philosophy, but to encounter our own yearning for permanence. Plato, Aristotle, and Descartes each offered visions that contrasted the eternal with the fragile, the immaterial with the mechanistic. Whether true or not, their ideas remind us of the question that science has yet to answer. What, if anything, endures when the body is gone? Eastern perspectives. While Western philosophy often framed the soul as a distinct immortal essence, Eastern traditions developed more fluid and cyclical visions of existence. Here, death is not an endpoint but a transformation, and memory is not confined to the individual but interwoven with the cosmos. Hinduism, Buddhism, and Taoism each offer perspectives that illuminate the tension between dissolution and continuity. In Hindu philosophy, the self called the Atman is eternal. Birth and death are stages in the cycle of samsara, the endless wheel of reincarnation. Each life is shaped by karma, the law of cause and effect that carries the imprint of actions across lifetimes. Unlike the Western view of a single life leading to eternal judgment, Hindu thought envisions continuity, a chain of selves, each linked through moral memory. Yet beyond this cycle lies liberation, moksha, where the Atman realizes its unity with Brahman, the cosmic soul. In this state, continuity dissolves into oneness, the drop returns to the ocean. Buddhism offers a different but related view. Here, the doctrine of Anatman denies any permanent, unchanging soul. Instead, the self is a bundle of processes, perceptions, thoughts, sensations that arise and pass away. Death, then, is not the departure of a soul, but the continuation of these processes in new forms guided by karma. Rebirth occurs, but without a permanent entity migrating from life to life. Continuity exists, but it is dynamic, not fixed. Memory, in this framework, is cosmic rather than personal. What carries over is not identity, but influence. Liberation comes through awakening to impermanence and escaping the cycle of rebirth in nirvana. Taoist philosophy brings yet another perspective. Rooted in the flow of the Tao, the underlying principle of harmony in nature, Taoism emphasizes dissolution into balance. Life and death are not opposites but phases in the rhythm of existence, like day and night, or growth and decay. The Taoist sage does not resist death but flows with it, seeing it as transformation rather than annihilation. Memory here is not preserved in individual continuity, but in participation in the greater cycles of the Tao. To live well is to align with the eternal patterns of nature, dissolving into them without fear. The contrast between these Eastern views and Western dualism is striking. In the West, the soul is often imagined as a fixed essence that either survives or perishes. In the East, continuity is relational, cyclical, and often impersonal. Hinduism emphasizes a chain of lives bound by moral causality. Buddhism sees continuity without a permanent self. Taoism embraces dissolution into harmony. Where Western thought often pits immortality against oblivion, Eastern thought finds meaning in transformation itself. For modern readers, these perspectives offer a different response to the fear of being forgotten. Memory, in these traditions, is not about being preserved as an individual, but about participating in continuity that transcends the self. Your life matters not because it is eternal, but because it contributes to the unfolding of a larger pattern. Continuity exists, but it is cosmic rather than personal. This shift can be both unsettling and liberating. To those who crave personal immortality, the idea of dissolution into oneness may feel like erasure. But to those who fear isolation, it offers belonging. The self is not abandoned but absorbed into something greater. In a universe governed by change, Eastern philosophies suggest peace lies not in resisting impermanence but in embracing it. Ultimately, Hinduism, Buddhism, and Taoism reframe the soul not as an isolated jewel, but as part of a living continuum. They teach that memory is not lost but transformed, woven into cycles, patterns, and flows that outlast the individual. In their contrast between dissolution and continuity, they invite us to see death not as an end, but as participation in the eternal rhythm of existence. Modern materialist rejections. For all the philosophical and spiritual visions of continuity souls, reincarnation, cosmic memory, modern science has carved out a starkly different position. Materialist accounts of the mind insist that consciousness is not an immaterial essence or cosmic vibration, but the activity of the brain itself. In this view, the self is a biological phenomenon, fragile and finite, extinguished when neural activity ceases. Continuity after death is not liberation, rebirth, or absorption into oneness. It is finality. Neuroscience provides the foundation for this rejection. Brain scans consistently reveal correlations between mental states and neural activity. Damage to specific regions alters personality, memory, or perception. Stimulation of neurons can evoke sensations or trigger recollections. Disorders such as Alzheimer's or strokes show how identity erodes with neural decline. To materialists, these findings are clear. Consciousness depends on the brain in the same way that music depends on an instrument. When the instrument breaks, the music ends. This perspective sharply contrasts with spiritual continuity. Where Plato envisioned an immortal soul and Hinduism described the eternal Atman, neuroscience describes emergent processes. The mind is not a separate entity but a pattern arising from electrical and chemical signals. Memories are encoded in synaptic connections. Thoughts are electrochemical firings. Emotions are hormonal responses. Continuity, in this account, is an illusion created by the brain's ability to link past, present, and future into narrative. Once the circuitry fails, the story ends. Materialists also argue that appeals to soul or reincarnation often arise from wishful thinking. The fear of being forgotten, the longing for permanence drive humans to invent metaphysical comforts. But for science, the absence of evidence is decisive. No experiment has detected souls leaving the body. No brain scan has revealed consciousness persisting independently of neurons. From this angle, death is not mystery but biology, a system shutting down, a process completing its course. Yet this rejection does not strip life of meaning. Many materialists find comfort in the idea that mortality makes existence precious. If life were infinite, moments might lose urgency. If memory were eternal, experience might blur into monotony. By embracing physical finality, materialism grounds value in the here and now. Love, art, and knowledge matter, not because they echo forever, but because they shine briefly. In this framework, impermanence is not despair, but motivation. The contrast with spiritual continuity is therefore twofold. First, materialism denies metaphysical guarantees, insisting on the sufficiency of the brain to explain consciousness. Second, it reframes meaning. Where spiritual systems promise survival, materialism locates purpose in transience. The body may be temporary, but the depth of living within that span is what matters. Still, this rejection faces challenges of its own. The hard problem of consciousness, why subjective experience arises at all, remains unsolved. Neuroscience can trace correlations between brain states and mental states, but it cannot yet explain why those processes feel like anything. Critics argue that materialism explains mechanism but not essence. Others note that human longing for continuity, while not proof, cannot be dismissed as irrelevant. The persistence of spiritual vision suggests that the story is not finished. Nevertheless, modern materialism stands as a counterweight to myths and metaphysics. It resists comforting illusions, demanding that claims about the soul be judged by evidence, not desire. It forces us to grapple with mortality without guarantees, confronting the possibility that death is final. In doing so, it sharpens the contrast at the heart of human inquiry. On one side lies spiritual continuity, the belief that something endures. On the other lies physical finality, the conviction that nothing does. Between them stretches the enduring question of what it means to live, knowing we may one day be forgotten. Entropy versus immortality. When we contemplate mortality, we often think of our own death or the fading of civilizations. But physics reminds us that impermanence operates on a grander scale. The universe itself has a destiny, and one of the most widely accepted scenarios for its far future is the heat death. This vision describes a cosmos ruled entirely by entropy, where energy is evenly distributed and no work can be done. It is the ultimate end not just of stars and galaxies, but of structure, memory, and life itself. The story begins with thermodynamics. Stars burn by fusing hydrogen into helium, releasing energy. Over billions of years, that fuel depletes. Galaxies slowly dim as stars exhaust their reserves. Black holes, once thought eternal, eventually evaporate through Hawking radiation. In this distant future, matter becomes diffuse, energy spreads thin, and temperature differences flatten out. With no gradients of energy to exploit, no processes can occur. The universe does not end in fire, but in silence, a cold equilibrium stretching into eternity. This image of cosmic death contrasts sharply with human dreams of immortality. Religions promise eternal soul, reincarnation, or heavenly continuance. Even secular hopes imagine humanity expanding into space, transcending death by colonizing the stars. But heat death suggests that no matter how far life spreads, it is temporary. All civilizations, however advanced, will eventually confront entropy's rule. Continuity may endure for billions or trillions of years, but not forever. The universe's ultimate fate is still erasure. For many, this is unsettling. The heat death scenario implies that meaning itself is temporary, not just on the personal or planetary scale, but cosmically. Every monument, every memory, every consciousness dissolves into thermodynamic equilibrium. The very laws of physics erase continuity. It is the coldest possible answer to humanity's longing for permanence. Yet some find a strange beauty here. Heat death underscores the fragility of life and the improbability of existence. The fact that we live during a cosmic window when stars still burn and complexity still thrives is itself miraculous. Against the backdrop of eventual silence, our brief moment of awareness becomes all the more precious. Just as personal mortality can inspire urgency, cosmic mortality can inspire awe. Physicists caution, however, that heat death is not the only possible future. Alternatives include the Big Rip, where dark energy accelerates expansion until all structures are torn apart, or a cyclic universe that collapses and begins anew. Still, heat death remains the most widely accepted outcome under current cosmological models, supported by observations of accelerating expansion and the relentless increase of entropy. The contrast between cosmic end and eternal soul could not be sharper. Spiritual traditions insist that consciousness or essence survives beyond decay, while physics points to a future where nothing remains but equilibrium. One offers comfort, the other finality, yet perhaps both reveal truths. The first about the human need for continuity, the second about the universe's indifference. To imagine the heat death of the universe is to confront the scale of impermanence. It stretches mortality beyond the individual, beyond the species, beyond even galaxies. In that vision, the human soul, whether real or metaphorical, stands against entropy as a protest of meaning. Even if the universe forgets, we remember here and now. Patterns that outlast matter. If matter and energy eventually succumb to entropy, is there anything that endures? While physics points to the dissolution of structures, many argue that patterns, mathematical truths, musical forms, and ideas possess a kind of immortality. They do not depend on physical persistence in the same way bodies or stars do. Instead, they exist as abstractions, capable of reappearing wherever minds or systems rediscover them. In this sense, continuity may lie not in matter, but in pattern. Mathematics provides the clearest example. The Pythagorean theorem, once discovered, seems eternal. Even if humanity vanishes, the relationship between the sides of a right triangle will still hold wherever geometry is considered. Prime numbers, Fibonacci sequences, and the laws of probability are not bound to culture or biology. They are woven into the logic of structure itself. Matter decays, but mathematics persists as truth, indifferent to time and entropy. Music illustrates another kind of persistence. A melody may vanish when instruments fall silent, yet it can always return if someone remembers or reconstructs it. The pattern of notes is not destroyed by the decay of sound waves. It survives in abstraction, carried in memory, notation, or rediscovery. Beethoven's symphonies continue to stir hearts centuries after his death, not because the original vibrations endure, but because the pattern is replicable across generations. In this way, music demonstrates how form can outlast material substrate. Ideas, too, reveal this power. Philosophies, myths, and scientific principles outlive the individuals who first conceived them. Plato's dialogues, Einstein's theories, and even anonymous folk tales persist as shared cultural patterns. They are transmitted, reinterpreted, and reshaped, but their core structures endure. While bodies decay and civilizations fall, ideas have the potential to leap across centuries, carried not by matter, but by meaning. The contrast here is profound. Material decay insists that everything physical dissolves, stars burn out, bodies rot, even galaxies scatter. Abstract persistence suggests that form, once realized, has a kind of timeless resilience. A mathematical law is not diminished by entropy. A melody is not erased by silence. An idea does not die when its author does. Patterns survive because they are not things but relations, capable of infinite expression. Of course, skeptics may object that patterns require carriers. A theorem exists only if some intelligence grasps it, a melody only if it is sung or written, an idea only if it is remembered. If all minds vanish in heat death, do patterns survive? Perhaps only in potential, waiting to be rediscovered by any future intelligence. In this sense, their immortality is conditional, not absolute, but latent in the structure of reality. Yet this conditionality does not diminish their significance. Patterns remind us that continuity need not mean permanence of matter. Meaning may lie in replication, not endurance. Your body will fade, but the ideas you share, the patterns you contribute to culture, can echo long after you are gone. The universe itself may forget eventually, but within the span of civilizations, patterns allow us to defy mortality. Philosophically, this offers a middle ground between despair and faith. We may not possess eternal souls in the traditional sense, but we participate in structures that transcend our lifespans. Mathematics, music, and ideas link us to something larger than ourselves. Patterns that endure even as the matter of our bodies dissolves. Perhaps immortality is not about escaping decay, but about contributing to forms that outlast it. The body is temporary, but the patterns it carries, thoughts, songs, insights, become part of a continuity that transcends matter. Entropy may dissolve structures, but it cannot erase the eternal language of form. Can consciousness survive entropy? Entropy confronts us with an unsettling vision that all structures, from stars to neurons, will one day dissolve. If consciousness arises from the brain, then it seems destined to perish along with the body. But is consciousness only a temporary flame, or could it endure as a deeper pattern woven into the universe? The question forces us to weigh annihilation against the possibility of conservation. From the materialist perspective, the answer is clear. Consciousness is an emergent property of the brain's electrochemical processes. Neurons fire, networks synchronize, and awareness arises. When those processes stop, whether through death, disease, or the universe's eventual decline, consciousness ends. In this view, there is no persistence beyond entropy. Consciousness is fragile, dependent on highly ordered structures, and entropy guarantees those structures will decay. Awareness, then, is a spark extinguished by thermodynamic inevitability. Yet speculation suggests alternatives. If consciousness is not merely emergent but fundamental like information itself, it may not vanish so easily. Some theorists propose that awareness could be a basic property of the universe, akin to space or time. This view, often associated with panpsychism, implies that consciousness is not destroyed by entropy, but redistributed, continuing in new forms as matter and energy shift. The individual flame may die, but the fire of awareness never goes out. Quantum theories of mind offer another possibility. If consciousness is tied to quantum processes, then perhaps it participates in the same conservation principles that protect information. Just as particles never truly vanish but transform, consciousness too might survive in ways we cannot yet measure. This does not guarantee personal immortality, but it raises the possibility that awareness, in some form, endures. There is also the idea of consciousness as pattern. Just as mathematics or music can persist independent of material carriers, perhaps consciousness is a kind of replicable structure. If the arrangement of thoughts, memories, and identity could be preserved or reinstantiated, then continuity might outlast decay. In speculative futures, advanced civilizations might archive minds in simulations or reconstruct them from cosmic imprints. Even if entropy erases the original, the pattern could survive elsewhere. The contrast here is stark. Annihilation insists that consciousness is temporary, bound to fragile order. Conservation imagines persistence whether through fundamental properties, quantum laws, or patterns. One strips meaning from mortality. The other imbues existence with continuity, but both views carry weight. The annihilation perspective grounds us in the urgency of life, reminding us that awareness is precious because it is fleeting. The conservation perspective connects us to the cosmos, offering hope that consciousness participates in something larger. Whether temporary flame or enduring pattern, consciousness becomes meaningful precisely because it inhabits the tension between fragility and persistence. Skeptics argue that conservation theories are poetic metaphors rather than evidence-based science. We have no proof that consciousness exists beyond the brain, nor that it can survive entropy. Advocates counter that absence of proof is not proof of absence and that mysteries remain, from the hard problem of subjective experience to the information paradox. Until these are resolved, the fate of consciousness remains an open question. Perhaps the truth lies not in certainty, but in humility. Consciousness may be temporary, yet its existence at all is extraordinary. To speculate that it might survive entropy is to honor the mystery it embodies. Whether it flickers out or endures as pattern, it reminds us of our deepest longing, that awareness, once lit, is too luminous to be forgotten. Memory beyond death. When we think of memory, we often imagine it as something contained within a single brain, a private archive of moments, feelings, and stories. Yet memory does not stop at the boundary of the skull. The thoughts we share ripple outward, leaving impressions on others, on culture, and even on history itself. In this sense, each mind is both a container and a transmitter, and forgetting at the individual level is counterbalanced by remembering at the collective one. Consider the way stories move between people. A memory of childhood told at a dinner table is absorbed by those who hear it, who may in turn recount it years later. Though the original thinker may forget, the echo persists. Every conversation, every written word, every recorded song carries traces of someone's inner life into the awareness of others. Our brains are porous. What begins as personal experience becomes part of a social network of remembrance. Culture amplifies these echoes. Myths, rituals, and art allow communities to preserve memory beyond individuals. The Epic of Gilgamesh, written thousands of years ago, still speaks to human longing for immortality. The works of Shakespeare continue to shape language and imagination centuries after his death. Scientific discoveries, once published, embed themselves into the fabric of knowledge, influencing generations of inquiry. Individual brains perish, but their patterns of thought translated into cultural forms extend across time. History represents the broadest layer of these echoes. Wars, migrations, inventions, and revolutions are remembered not only through artifacts, but through narratives carried forward by societies. Collective memory is imperfect, prone to distortion, but it is powerful. It shapes identity, informs decisions, and provides continuity across centuries. An individual's memory may fade in decades, but cultural and historical echoes can persist for millennia. The contrast between individual forgetting and collective remembering is striking. Individually, memory is fragile. Neurons die, synapses weaken, and recollections blur. Even in life, much is forgotten, and after death, personal archives vanish. But collectively, memory accumulates. It is externalized into books, architecture, art, and oral traditions. Human culture is, in many ways, a vast prosthetic memory, a way of preserving what no single brain could contain. This raises profound questions about identity and continuity. Do we live on through the echoes we leave in others? If a person's laughter, wisdom, or creativity continues to shape lives after they are gone, is that not a form of survival? While materialists deny immortality of the soul, they acknowledge the persistence of influence. Memory, refracted through others, is not the same as personal continuity, but it is continuity nonetheless. Yet echoes are never perfect copies. They distort as they spread, altered by interpretation and retelling. Cultural memory is as much invention as preservation, weaving fragments into narratives that serve present needs. In this sense, collective remembering both rescues and transforms. The original may be forgotten, but something of it, an impression, an essence, endures. Philosophically, this vision provides a middle ground between despair and comfort. Absolute oblivion is rare. Most lives leave traces, however faint. A gesture of kindness remembered by a child, a story passed through friends, an idea embedded in a field of study, all are echoes. They may not preserve the individual self in its entirety, but they testify that memory does not end where one brain ends. The brain's echoes remind us that we are both finite and extended. Our private memories fade, but our thoughts ripple outward into others, into culture, into history. Forgetting and remembering are not opposites, but partners. What one person loses, a community may carry. To live, then, is not only to experience, but to echo and to trust that somewhere in someone, the reverberations of our minds will continue. Quantum information and consciousness. If physics teaches that information can never be destroyed, could this principle apply to consciousness itself? Some thinkers speculate that the mind might not be merely a byproduct of the brain, but a manifestation of quantum information in tangled states woven into the fabric of reality. If so, then perhaps consciousness, like other quantum information, cannot be lost. This idea is tantalizing, but it sits uneasily at the border between science and speculation. The hypothesis begins with quantum theory. At the smallest scales, particles exist not as fixed objects but as probabilities described by wave functions. When particles become entangled, their states correlate instantaneously, no matter the distance between them. Physicists have confirmed that entanglement preserves information across space in ways that defy classical intuition. This resilience has inspired some to wonder, could consciousness itself be a kind of entangled process, encoded not only in neurons but in the quantum structure of reality? Proponents of this view point to models like the Orc-OR theory advanced by Roger Penrose and Stuart Hameroff, which argues that consciousness arises from quantum processes in microtubules inside neurons. If correct, the mind would not be fully explainable by classical biology. Instead, it would hinge on quantum information, an entity known to resist destruction. Death might dissolve the biological platform, but the quantum information underpinning awareness could persist, woven into the universe like radiation from a vanished star. This contrasts with the mainstream scientific position, which remains skeptical. Most neuroscientists argue that consciousness can be explained by classical processes, networks of neurons exchanging electrochemical signals. Brain activity is noisy, warm, and wet conditions typically hostile to fragile quantum states. To them, the leap from quantum physics to subjective experience is speculative at best, pseudo-scientific at worst. While entanglement is real, applying it to consciousness stretches evidence beyond recognition. Fringe theories, however, persist because they address the hard problem of consciousness, why physical processes should give rise to subjective experience at all. Mainstream neuroscience explains correlations but not essence. Quantum models, though unproven, attempt to bridge this gap, suggesting that consciousness is not reducible to matter but reflects a deeper informational order. To those drawn to this vision, the persistence of quantum information hints that awareness too might escape annihilation. The contrast is therefore sharp. Mainstream doubt insists that until evidence shows otherwise, consciousness remains tethered to brain activity, and dies with it. Fringe theories propose that mind may be entangled with the cosmos, its informational traces conserved beyond decay. One position grounds us in biological finality. The other invites speculation about immortality, not as spirit, but as physics. Philosophically, this tension reveals more about human longing than about settled science. We fear that consciousness ends, and so we search for frameworks that might preserve it. Quantum information becomes a candidate because it is mysterious, resilient, and already reshaping technology. Whether or not the link to mind is valid, the idea satisfies our desire to imagine that awareness, once sparked, cannot simply vanish into nothing. Skeptics remind us that extraordinary claims demand extraordinary evidence. No experiment has shown that consciousness survives death as quantum information. Yet the absence of evidence does not erase the question. The mystery of mind remains unsolved, and the allure of quantum persistence keeps the door ajar. The speculation forces us to confront two possibilities. Either consciousness is a temporary flame, extinguished with the brain, or it is entangled information, conserved like all else in the universe. Between mainstream doubt and fringe hope lies the space of wonder, where physics brushes against philosophy and where the deepest human question persists. Does awareness, once lived, ever truly die? The Akashic Field. Hypothesis. Among mystical traditions, few ideas are as evocative as the Akashic Field, a universal memory bank where every thought, action, and event is eternally recorded. Rooted in ancient Indian philosophy, the term Akasha refers to the subtle ether that underlies existence, the space in which all phenomena occur. Later spiritual movements, particularly Theosophy and New Age thought, developed the concept into a cosmic archive, the so-called Akashic Records. According to this vision, nothing is ever lost. The universe itself remembers everything. The appeal is obvious. The Akashic Field provides comfort against oblivion, suggesting that our lives are preserved beyond physical decay. Every gesture, intention, and experience is woven into the eternal fabric, accessible to those capable of heightened perception. Mystics claim that saints, prophets, or spiritual adepts have glimpsed this archive, drawing on it for visions of past lives, insights into the future, or profound wisdom. For many seekers, the Akashic Field represents both continuity and justice. No deed goes unnoticed, no life is meaningless. Scientific perspectives, however, approach this idea with caution. Physics has no evidence for an all-encompassing memory field beyond matter and energy. While information theory suggests that traces of events persist in physical systems, this is far from the mystical claim of an infinite cosmic library. To scientists, the Akashic Field belongs more to metaphor and mythology than to empirical reality. Attempts to link it to quantum fields, zero-point energy, or holographic principles often blur rigorous distinctions, trading precision for poetry. The contrast between mystical tradition and scientific caution is striking. The Akashic Field asserts purposeful remembrance. The cosmos not only conserves information, but does so with meaning and accessibility. Science, by contrast, limits itself to demonstrable conservation. Black holes may scramble data, but physics seeks mathematical laws, not mystical records. Where spirituality hears whispers of destiny, science hears metaphors stretched too far. Yet the hypothesis persists because it resonates with deep human needs. We fear being forgotten, and the idea of a universal memory offers reassurance. We long for justice, and a cosmic archive implies accountability. We seek connection, and the Akashic Field suggests we are part of an ongoing story larger than ourselves. Even skeptics admit the psychological power of the image. It transforms the indifferent universe into a witness. Some thinkers try to bridge the divide by treating the Akashic Field as symbolic rather than literal. Perhaps it is less a physical structure than a metaphor for interconnectedness, our memories living on through culture. our actions rippling through history, our consciousness embedded in networks larger than the self. From this angle, the Akashic field expresses truths about interdependence, even if it does not exist as a measurable phenomenon. Still, others hold that science itself may one day stumble towards something resembling the Akashic vision. Concepts like the holographic principle, quantum entanglement, and universal information conservation hint at deeper layers of reality. Whether those layers amount to a cosmic memory field is uncertain, but they demonstrate that the boundary between physics and mysticism is not always fixed. The Akashic field may be myth, but myth has a way of anticipating questions science later explores. The Akashic hypothesis invites us to hold two truths in tension. Scientifically, there is no proof of a universal record. Spiritually, the belief endures, offering solace and meaning. The field may never be found in equations, but as a symbol of memory and continuity, it continues to shape how we imagine our place in the cosmos. Skepticism, science and hope for all the myths, speculations, and spiritual traditions that imagine memory as immortal. The mainstream scientific view remains blunt. The universe does not keep personal records of our lives. Consciousness is not eternal. Memory is not indestructible. And when the brain dies, the patterns that defined a person dissolve. Science says no, not out of coldness, but because its method demands evidence. Where hope reaches beyond data, empiricism draws the line. Neuroscience leads the dismissal. Decades of research show that memories are encoded in neural networks' patterns of synaptic strength shaped by experience. When neurons die, as in Alzheimer's disease, memory fragments and disappears. Brain injuries can erase entire decades of experience, revealing how fragile and localized memory truly is. If recollections were stored in some cosmic archive, such losses would be inexplicable. Instead, the evidence points to memory as wholly dependent on physical substrates, vulnerable to decay. Physics reinforces the rejection, while theories like the conservation of information prevent total annihilation in a mathematical sense. That does not mean the universe preserves memory in any usable form. When a book burns, the smoke and ash contain information, but not the story. Likewise, the photons and particles radiated from the body encode traces but not consciousness. Information persistence is not the same as personal continuity. Romantic hopes confuse metaphor with mechanism. Moreover, science warns against anthropomorphizing the cosmos. To imagine the universe as a record keeper is to project human categories onto indifferent physical processes. Stars collapse, galaxies collide, particles scatter, not because they preserve stories, but because they obey natural laws. To speak of memory at cosmic scales risks misleading analogy. For science, the universe does not remember. It simply evolves. This strict empiricism often frustrates those drawn to visions of cosmic continuity. It seems to reduce life to chemistry and decay, stripping away meaning. But from the scientific perspective, clarity itself is meaning. Facing the limits of memory forces us to value what we have while it lasts. Instead of promising immortality, science emphasizes impermanence as the condition that makes life urgent and precious. The contrast between romantic hope and scientific rigor is sharp. Hopes of immortal memory offer comfort, the assurance that nothing is lost, that we continue beyond death. Science denies that comfort, insisting on the evidence of decay. Yet this denial is not cruelty, it is fidelity to what can be measured and verified. By rejecting unwarranted claims, science preserves its credibility and its power to uncover truths about the world. Still, even within science, humility persists. Physicists admit that mysteries remain: the nature of consciousness, the fate of information in black holes, the deep structure of space-time. Neuroscientists acknowledge that memory is not fully understood, that subjective experience resists complete explanation. Science says no to immortal memory not because it has solved every puzzle, but because no evidence yet justifies a yes. Its refusal is provisional, grounded in the method of doubt. To many, this stance feels unsatisfying, even bleak. But perhaps it is also liberating. If memory is not immortal, then the meaning of life shifts from eternity to immediacy. What matters is not whether we are preserved forever, but how fully we live now in this fragile span of awareness. Romantic hopes look to continuity. Science points us back to presence. The scientific no is not the end of the story, but one side of the dialogue. Against the vastness of longing, it asserts the discipline of evidence. Against dreams of immortal memory, it offers the clarity of impermanence. And in that contrast, the human search for meaning continues, suspended between what we hope and what we know. Why humans refuse oblivion? If science dismisses immortal memory, why do humans cling so fiercely to the belief that something must endure? Across cultures and ages, people have invented myths of afterlives, souls, and cosmic archives. Even in secular societies, we seek continuity through legacy, art, or digital traces. The refusal of oblivion is not accidental. It arises from deep psychological and evolutionary roots. At the evolutionary level, persistence is survival. Organisms are wired to preserve themselves, to resist decay and death. The fear of annihilation motivates caution, planning, and resilience. Without it, our ancestors would have taken reckless risks and vanished. From this perspective, the longing for continuity may be an extension of biology, the instinct to survive projected beyond the limits of life. Myths of immortality and memory can be seen as adaptive fictions, encouraging individuals to act with care and hope. Yet the need runs deeper than pragmatism. Humans are self-aware. We not only live, we know that we live. This awareness brings with it the knowledge of mortality. Unlike other animals, we imagine our own absence, and that thought terrifies us. To confront the possibility of oblivion is to face existential dread, the sense that all meaning could dissolve into nothingness. Belief in persistence, whether through soul, reincarnation, or cosmic memory, provides a shield against that dread. It assures us that our existence matters beyond its fragile span. Psychology reinforces this tendency. Studies show that people who believe in some form of afterlife often experience less death anxiety. Cultural worldviews that promise continuity, whether through religion or collective legacy, help individuals cope with loss and mortality. Even in secular contexts, we construct symbolic immortality. Parents see themselves in their children, artists in their creations, scientists in their discoveries. These continuities soften the sting of death, offering echoes, if not permanence. The contrast between evolutionary pragmatism and existential dread is revealing. Evolution explains the roots of survival instinct, but it does not capture the full scope of human imagination. Existential dread transforms survival into metaphysics, turning biological fear into philosophical yearning. We do not merely want to live longer, we want to be remembered, to matter in a universe that otherwise seems indifferent. Cultural diversity illustrates this vividly. Egyptians built pyramids to outlast time. Hindus embraced cycles of rebirth. Christians envisioned eternal souls in heaven. Taoists saw dissolution into the flow of the Tao. Each culture responded differently, yet all resisted the idea that life ends in nothing. Oblivion, it seems, is universally intolerable. Critics argue that this refusal is wishful thinking. Oblivion may be real, but humans invent stories to deny it. From this angle, myths of immortality are comforting illusions, evolved to keep us from despair. Yet even if untrue, they serve a purpose. They allow us to live with courage, to endure loss, to invest in futures we will never see. Belief in persistence is not merely false hope, it is part of what makes civilization possible. Still, the tension remains. Science offers no evidence that memory or soul endures. Psychology explains why we long for it. Evolution reveals why we are wired to resist death. And yet, the longing persists, powerful as ever. Perhaps refusal of oblivion is not a flaw, but a feature, a testament to the human capacity to imagine beyond survival. humans may never accept nothingness. Whether through children, culture, or cosmic speculation, we weave stories of persistence. Oblivion may be the truth, but yearning for continuity is our defiance. It is the spark that keeps us searching for meaning, even in the face of silence. Between proof and faith, some questions resist resolution. Does consciousness survive death? Does the universe remember? Are we more than fragile bodies? Science demands proof, belief demands trust, and awe often lives between them. At this boundary lies the enduring human struggle. To reconcile the clarity of evidence with the hunger for meaning. Science insists on rigor. Proof requires measurable data, repeatable experiments, falsifiable predictions. Without these, claims drift into speculation. Neuroscience shows that memory is encoded in the brain and vanishes with its decay. Physics demonstrates that while information may be conserved, it is scrambled beyond recognition. From this perspective, continuity beyond death is unsupported, however appealing it may be. Certainty, in the scientific sense, is a discipline of limits. Faith, by contrast, thrives in possibility. It does not need measurement to trust in continuity, whether through soul, reincarnation, or cosmic remembrance. Faith is not constrained by what can be tested. It rests on meaning, intuition, and hope. To believe is to say, even if I cannot prove it, I choose to trust it. This refusal to wait for evidence gives faith its power, offering comfort where science offers silence. The contrast between certainty and wonder is sharp. Certainty narrows, defining what we know and where the boundaries lie. Wonder expands, asking what might be beyond those boundaries. Proof reassures us with precision, or unsettles us with possibility. Both are necessary. Without proof, we risk delusion. Without wonder, we risk despair. Philosophers have long recognized this tension. Blaise Pascal wrote of the infinite abyss in the human heart that only faith could fill. Albert Einstein spoke of cosmic religious feeling, a sense of awe that fueled scientific discovery. For Pascal, faith answered the unknown. For Einstein, wonder drove the search for proof. In both cases, the interplay between science and belief was not antagonism but dialogue. This boundary is where awe thrives. To contemplate the universe, its vastness, its strangeness, its silence, is to encounter questions too large for certainty alone. Why is there something rather than nothing? Why do we experience awareness at all? These mysteries may one day be illuminated, or they may forever elude resolution. Either way, they invite humility. Awe is the recognition that we stand in the presence of the unknown, unable to capture it fully, yet enlarged by the attempt. Living between proof and faith requires balance. Too much reliance on proof can leave life feeling barren, stripped of mystery. Too much reliance on faith can drift into fantasy, detached from reality. But together they shape a richer human experience. Science grounds us, faith uplifts us, and awe unites them. The task is not to choose one over the other, but to dwell in their dialogue, honoring both clarity and wonder. Perhaps the purpose of these questions is not to find final answers, but to transform how we live. Proof teaches us to respect limits. Faith teaches us to hope beyond them. Awe teaches us to cherish the mystery itself. Between certainty and wonder, we become seekers, humbled by what we do not know, yet emboldened to keep asking. To stand at this boundary is to be human, finite, curious, yearning. Proof gives us knowledge, faith gives us meaning, and awe reminds us that even without resolution, the mystery itself is worth living for. Does the universe remember us? As we near the end of this exploration, it is worth returning to the ground most solid beneath our feet, physics. For all the speculation about souls, reincarnation, or cosmic archives, the natural sciences remain our clearest lens on reality. What then does physics actually suggest about memory, continuity, and the possibility of persistence beyond death? The answers are not always comforting, but they are profound. The most sobering principle is entropy. The second law of thermodynamics insists that systems evolve toward higher probabilities, scattering order into disorder. Entropy explains why bodies decay, why civilizations collapse, why stars eventually burn out. From this perspective, death is not anomaly but inevitability, the dispersal of complex order into simpler states. Consciousness, dependent on the fragile structures of the brain, is especially vulnerable. Once the neuronal networks dissolve, memory ceases. Entropy suggests finality, a universe where forgetting is not just personal, but cosmic. Yet physics also offers a counterpoint through the principle of information conservation. While entropy scatters structures, information, the underlying description of a system's states, may never be truly destroyed. The debate over black holes illustrates this tension vividly. Stephen Hawking's early work suggested that black holes annihilate information, swallowing matter and memory alike into oblivion. But later theories, supported by quantum mechanics, argue the opposite. Information is scrambled but preserved, perhaps encoded on the event horizon in line with the holographic principle. If true, this means the universe, at its deepest level, refuses erasure. Nothing is ever wholly forgotten. This contrast between destruction and conservation defines the paradox at the heart of physics. On one side, entropy ensures decay. On the other, quantum theory insists on preservation. A burned book is no longer legible, but the ash and photons still contain traces of its content. Likewise, a human life may end, but its informational imprint through particles, energy, and subtle correlations remains etched into the cosmos. Whether those traces are ever accessible is another question, but their persistence suggests a universe that remembers, even if blindly. Beyond black holes, physics points to patterns of memory woven into reality itself. The cosmic microwave background preserves a snapshot of the early universe, a faint glow carrying details from nearly 14 billion years ago. Gravitational waves ripple outward from collisions of massive objects, embedding their histories into space-time. Every particle interaction leaves echoes in the unfolding state of the cosmos. If we define memory as the persistence of traces, then the universe is saturated with it. Still, physics is cautious about linking these principles to consciousness. Information conservation does not guarantee personal survival. The scrambled traces of a life may exist, but not as coherent memory or enduring identity. Entropy erases form even if it spares fragments. From a scientific standpoint, the universe remembers everything, but not in a way that restores the self. Memory is conserved but not meaningfully accessible. This contrast is stark. Destruction reminds us of the fragility of structure. Conservation hints at hidden permanence. The tension between them embodies the complexity of physics. It denies easy comfort while refusing to collapse into despair. The universe is neither wholly forgetful nor fully remembering. It is a system where traces endure even as forms dissolve. For human beings, this paradox is both unsettling and inspiring. If nothing is ever fully lost, then our lives, however brief, are woven permanently into the fabric of reality. Yet if entropy erases coherence, then our identities as we know them are fleeting. Physics suggests that we are both eternal and transient patterns that persist, selves that vanish. Perhaps this is the final gift of science, not certainty, but humility. Entropy teaches us that nothing lasts unchanged. Information conservation teaches us that nothing is truly erased. Between these truths lies the mystery of existence, a universe that forgets form but remembers traces, that dissolves lives yet preserves their echoes. What physics suggests ultimately is that even in a cosmos of impermanence, nothing we are is ever entirely gone. The soul as pattern. What if the soul is not a ghostly essence, nor a metaphysical spark, but something closer to physics, a pattern? In this vision, what survives is not a substance floating free of the body, but the structure of information that makes us who we are. The body may perish, the brain may dissolve, but the pattern woven into matter, memory, and interaction may persist. The soul then is not material, yet not mystical either. It is informational. This idea gains strength from how science already describes the self. Neuroscience shows that memory and identity emerge from networks of neurons firing in complex synchrony. There is no single location of the self in the brain. Rather, selfhood is distributed across patterns of activity. Destroy enough of those patterns and personality erodes. Preserve them and continuity remains. If we define the soul as that which carries identity, then what matters is not the flesh, but the form, the arrangement of information that encodes us. Physics too hints at the durability of patterns. The principle of information conservation suggests that while structures decay, the information they embodied is not annihilated. Like a melody that disappears from the air yet survives in notation, patterns may persist beyond the material forms that first expressed them. Entropy dissolves matter, but it does not erase the logic of relationships. In this light, the soul may be viewed as a pattern resilient to destruction, capable of re-emerging wherever the universe reconstructs it. This view contrasts starkly with the fragility of the body. The body ages, suffers injury, and ultimately succumbs to entropy. Its cells break down, its organs fail, its memories fade. If the soul were merely body, there could be no survival. But if the soul is pattern, then it is as indestructible as mathematics. The Pythagorean theorem does not cease to exist when its discoverer dies. A poem does not vanish when the paper burns, so long as someone remembers or rewrites it. In the same way, the pattern of a self may be more enduring than the matter that carried it. Of course, this raises questions. Where would such patterns persist? One possibility is cultural. The soul lives on in the memories of others, in stories, art, or influence. Another is cosmic. If information is conserved, then the universe itself retains the patterns we embodied, however scrambled. Some speculate that advanced civilizations or future technologies might even recover these patterns, reassembling them as digital or physical continuities. The soul in this futuristic view is not metaphysical but reconstructible. Skeptics caution against romanticizing the metaphor. A pattern is not a person. The notation of a symphony is not the same as the music played. The mathematical description of a life is not the lived experience. Information may persist, but identity may not. What endures could be fragments, not continuity echoes, not essence. The difference between soul as pattern and soul as self may be the difference between permanence and meaning. Yet even as metaphor, the idea is powerful. It bridges science and spirituality, offering a way to imagine survival without abandoning physics. It suggests that we are not defined solely by fragile bodies, but by the forms they manifest, forms that belong to the universe's deeper architecture. If matter is transient but information is durable, then perhaps what we call soul is less ghost than geometry, the enduring pattern of identity. The contrast, then, is clear. The fragile body reminds us of mortality, while the indestructible pattern offers continuity. Between them lies the mystery of self, ephemeral yet enduring, local yet universal. Whether or not the pattern of a soul can ever be recovered, the notion reshapes how we see ourselves. We are not only flesh, we are form, and form, unlike flesh, may outlast decay, living with cosmic memory. If the universe remembers, if every action, thought, and pattern leaves an imprint woven into the fabric of reality, then how should we live? This question transforms cosmic speculation into personal responsibility. For in a universe where nothing is ever truly lost, every choice matters twice, once in its immediate effect, and again in its contribution to the eternal archive. The idea of cosmic memory invites awe. Physics suggests that information is conserved, encoded in subtle correlations, even when forms dissolve. Mystical traditions imagine a universal record, the Akashic field, where nothing vanishes. Whether through quantum law or spiritual metaphor, the implication is the same. We are participants in a story that endures beyond us. To live is to inscribe ourselves into the cosmos, our lives etched in traces that cannot be erased. Faced with this vision, some might feel crushed by the weight of permanence. If the universe remembers everything, then every mistake, cruelty, or failure is eternal. This can foster despair, the sense that nothing can be undone, that we are trapped in the permanence of our flaws. Nihilism lurks here too. If all is preserved indiscriminately, then perhaps nothing truly matters, since beauty and horror are equally eternal. Yet cosmic memory can also inspire the opposite, meaning rooted in responsibility. If our imprints endure, then kindness resonates just as lastingly as cruelty. Love, creativity, and generosity ripple outward, not only shaping immediate lives but also weaving into the universe's record. The permanence of memory transforms morality from preference into participation in cosmic order. To act well is to harmonize with eternity. To act poorly is to fracture it. This contrast between nihilism and meaning reflects the paradox of memory itself. Memory is impartial, it preserves both the noble and the trivial, but how we interpret that fact depends on our stance. Nihilism sees futility. If all persists, nothing distinguishes itself. Responsibility sees significance. If all persists, then every act is weighty. The choice is ours, and in that choice lies the essence of freedom. Living with cosmic memory also reshapes how we understand mortality. Death no longer signals total oblivion but transformation. Our bodies decay, but their atoms endure. Our thoughts vanish from personal recall, but their traces linger in culture, history, or physical imprints. Even if our identities dissolve, something of us persists. This perspective does not guarantee personal immortality, but it does grant continuity. We belong to a universe that forgets nothing, and thus, in some sense, we are eternal. Philosophically, this vision recalls ancient traditions. Stoics urged living with integrity because the cosmos is rational order. Buddhists emphasize compassion because actions ripple across cycles of rebirth. Today, physics offers a secular parallel. Entropy dissolves structures, but information persists. The universe, whether conscious or not, functions as memory. To recognize this is to recognize that our lives matter, not in spite of impermanence, but because their traces endure. Practically, living with cosmic memory means embracing both humility and purpose. Humility because we are small participants in a vast, indifferent system that records us without judgment. Purpose because our contributions, however fleeting, are indelible. Every kindness offered, every cruelty inflicted, every creation born of imagination leaves its mark. We cannot escape being remembered, but we can shape what is remembered. Cosmic memory is less about survival than about significance. It does not promise that the self will live on intact, but it insists that nothing is meaningless. To live with this awareness is to walk a path between awe and responsibility. To see each act as part of an eternal archive. If the universe remembers, then our task is simple yet profound, to live as though our lives echo forever. Because in some deep, mysterious way they already do.